Madan Mohan did her schooling at KV Kalpakkam. She has completed her BE in Electronics and Communication from Government College of Technology, Coimbatore in 1989. She took up her career as a lecturer at Hindustan College of Engineering in 1990. After 4 years of teaching experience, she joined Indira Gandhi Center for Atomic Research at Kalpakkam as an instrumentation engineer with the chemistry group of IGCAR Kalpakkam. Having worked in low temperature measurements and data acquisition systems for various analytical instruments, she completed 14 years in that role. During this period, she completed her MS from BITS Pilani. Then she moved on to strategic planning and human resource section and continued with the bar training school at IGCAR campus. In addition to teaching,
please go to Sony Live and start watching Rocket Boys. You will see the struggle of Homi Jahangir Baba and Vikram Sarabhai. They both are born into rich families, but they struggled to establish excellent laboratories. They struggled to bring basic science research and struggled to make a vision for this country. This all will tell you as envisaged by Homi Jahangir Baba. He said that we will have pressurized heavy water reactors where you use natural uranium, whatever uranium is available. Then the second stage is when you are using natural uranium in the first stage, some of the uranium, that is uranium-238, it consists of natural uranium consists of uranium-238 and uranium-235. 235, which will undergo fission, is only 0.7%, but 99.3% is going to be uranium-238, which will not undergo fission. But slowly they will start getting converted to plutonium, not the entire bunch, not at all the entire bunch. Just some 5 to 10% of that uranium will get converted to plutonium. So once the fuel is taken out, you will reprocess it after cooling period. Cooling period itself is 3 to 7 years. After the cooling period, you reprocess it, you will find plutonium. Like this, at least for 40 to 50 years, when you start operating on the first stage reactor, you will get from the used fuel almost enough of plutonium to run the second stage. The second stage program, when you are seeing in that, is Kalpakkam's fast breeder test reactor, which was started in 85. This is with the first, and initially we didn't have oxide fuel. So we, because the other countries also stopped. In fact, our design is Rhapsody design of France. They are specialized in breeder reactors. They, Russia and all, are having big breeder reactors. As such breeder reactors, many countries are not having because plutonium is one. Plutonium is also used for missile. So somehow everybody is not following it. Because we are not having very high uranium, natural uranium resource, we thought we'll start slowly getting into second stage, where we will be, the second stage will help you use every bit of your fuel that is available with you. Because the first stage, after conversion, will give you plutonium, and the remaining, which is not converted, also will be used together in the, as a blanket here to produce more of plutonium. Different energy sources. Wind power. Wind power means, see, for, you can see that wherever the wind power is, it will almost barren type. You cannot have big trees and all. So carbon sink is lost. And then this is the area required for a mid-sized town is required for establishing 75 megawatt solar energy. But that way I should appreciate Tamil Nadu. They've gone in for all sources. Thermal is there, coal, Metur there, Ennur plant is there, Neyveli is there. And then you have hydro projects are there. At Kunda you have near Ooty. At Pavanasam you have, wherever you have river, Vaigai Dam, wherever you have hydro also is there. Hydro project is also there. And then wind, you know, Kaitar and Kanyakumari district, you can see a lot of windmills are there. That is one advantage. During May to September, always this wind energy from these wind turbines are connected to our grid, and Tamil Nadu has been able to tide over this situation of, you know, the excess power requirement is during May to September, our summer. In fact, our Chennai climate is only hottest. We don't have anything like cold and all here. So for the hottest, we need all these released during the fission of an atom. Nuclear energy and is a way to generate heat using the fission process of atom, and nuclear power plant converts the heat into electricity. Nuclear power plant uses the heat produced from splitting of atom to generate steam. That steam will go and run the turbine. Turbine is connected to your generator, and electricity is produced. It is also actually like a coal plant or anything. It's available for very large time. Like it is reliable, highly reliable. and it runs continuously for a long time. It can take base load, and the amount of fuel required is very, very small. When amount of fuel required is small, you know that the waste also is going to be very small. And nuclear energy continues to grow and perform very well. If you see in 2019, 5 gigawatts of nuclear power could not be connected to the grid because of maintenance worldwide. But the rest of the available increase the power production by 95 terawatt hours. So that is the up and available position. This is one small, for you to see the fission. How a fission happens. That most of you will be wondering how fission happens. So first of all, you cannot see the atom. Uranium 235 kanduku theriyadu. Neutron suttama kanduku theriyadu. So this neutron goes and hits the uranium 235. It can split into krypton or barium and release 2-3 neutrons. Actually, it will not be exactly krypton barium. Mostly it will be krypton barium. It can be molybdenum lanthanide and 2 neutrons. So the average neutrons produces 2.3 neutron per fission. Because sometimes 2 neutrons come, sometimes 3 neutrons come. These neutrons go and strike the next atom. When you talk about nuclear plant and thermal plant, nuclear plant is clean and environment friendly. Why? The land required is very, very less compared to thermal, hydel, wind, solar, anything. Fuel, if you see, only 50 to 100 tons of uranium is required per year, and the transportation is also easy. You take it in truck. Environmental impact, we don't have any greenhouse gases, no acid rain. Just look at the thermal. 70,000 tons of 70 lakh tons of carbon dioxide, 20,000 sulfur oxide, 4 lakh tons of ash. That ash, now they're making bricks out of it for building construction. In Chennai, you'll be seeing grey color bricks, not the earlier red color. Grey color bricks are coming from Neyveli. That ash, from the ash, what they compress and make. Radiation, it's only 1% of AERV limit, 0.5% of natural background. Natural background is 2.4 millisievert. Ours is only 0.5% of natural background is coming out. And what is that? This actually what happened is that fly ash is it emit radiation due to presence of radon 226, radon 228, and K40. So not only thermal plant is also giving out radiation because of the presence of this radioactive element in their ash. This is just a pictorial way of presenting it. Now, if you look at this, you have thermal plant, you have coal plant. A coal will have, in electricity from 1 kilogram of coal will be only 3 kilowatt hour. If I want to use 1 kg of oil, I get only, but if I'm using 1 kg of uranium, I get 50,000 kilowatt. And if I reprocess that, I take out plutonium and then start using it, I get 35 lakh kilowatt hour. So that is the advantage to dispose. If you look at our PHWR program, it started from 230 megawatts, 220 megawatts. If you see, they are running like this. 230, if you see, you had first RAPS coming up. The first one was, these are all RAPS is technology demonstration. Before that, you have boiling water reactor at Tarapur. That was imported by US collaboration. Then demonstration, this BRC had made it, RAPS 1 and 2. Then 1980s indigenization, we thought, okay, we ourselves will do everything, and MAPS Alpacam is the one where our own scientists and engineers had done everything. It is totally indigenous. 1980s, you started standardizing. Based on the MAPS success, we standardized, and then we started becoming expert in that. Even we constructed Kaiga plant ahead of its time, 4.5 years itself. Then what we did is, Tarapur, slowly we went to, slightly we thought, let us increase output. We designed for 540. 540 is a big success, but based on 540 success, we made small changes and we made it a 700 megawatt. 700 megawatt, the first one is the Kakarparas in Gujarat. It was connected to the grid on January 2021. So this is our... For what are all the applications, you can avoid the sprouting of potatoes and onions. For all you know, you may be eating already irradiated of potatoes and onions. None of us know. Anyway, the food is tasting good. We are all not getting cancer or anything because of the food that you eat. It is like taking X-ray. When you take X-ray, do you store your X-rays in your body? No, it just passes through and give where your bonus crack. Same way, you will be passing through the conveyor belt for few seconds only all these food items, and there will be gamma source, cobalt-60 or cesium-137, which will be emitting the gamma source, and that will irradiate the food particles, which will help in keeping insect infestation will be avoided, and shelf life extension is done, especially for army and all. When you have to send food, you have to irradiate them and send for longer shelf life. Hygienization, you can always treat it. In fact, now also from the hospitals and all, some of the items during pandemic, they were using a lot of items. Instead of throwing and creating more waste, we used to sterilize it using radiation. So radiation application is, this is one picture of yield. See, it's showing about cobalt-60 and cesium-137. There's so many other applications you can go. So need for nuclear energy, it is the future need for power with very high quality power with less greenhouse gases or nil greenhouse gases. Huge gap between the supply and demand is there. So we will have to start working on it. Explosive population growth is there for people. The supply and demand of various sources. So we have to start adopting nuclear also. Mega sources of coal, gas, oil and all are very less. Hydropower is again rain dependent. Wind and solar are poor load factor. Seasonal again. Zero emission of greenhouse gases and abundant thorium reserve in India. Based on all this, we know that we need nuclear power for the country.
I would like to invite Dr. D. Shailaja ma'am to propose the vote of thanks.
It gives me immense pleasure to deliver the vote of thanks for this webinar, orientation program on the opportunities in DAE. First and foremost, I would like to thank the resource persons, Dr. R. Venkateshan, Division Head, Radiological and Environmental Safety Division, IGGAR, Chennai. Then Mrs. Jalaja Madan Mohan, Head Technical Coordination, Public Awareness Section, IGGAR, Chennai, and Mr. K. Parthiban, Scientific Officer E, IGGAR, Chennai, who despite their busy schedule have found time to raise this occasion. I express my heartfelt thanks to Shri Ashok Kumar Mundraji, our Secretary, for his guidance and his valuable contribution. I thank our Principal, Captain D.S. Dr. S. Santosh Babu Sir, for his support and commitment. My heartfelt thanks to our beloved Head of the Department, Dr. D. Shamala, for her motivation, guidance, and encouragement. I'd like to extend my heartfelt thanks to the HODs, staff, and students of Department of Chemistry, Biochemistry, Biotechnology, Microbiology, and my colleagues who have coordinated to make this event a great success. I would also like to thank the student coordinator, Saraswati of 2nd MSc Physics. Last but not the least, I would like to thank all the students for their cooperation and participation. Thank you all.
Thank you very much, madam. Our information center at Shastri Bhavan is open to all the students. Whenever you want, you can just send a mail or you can collect a phone number from madam. Just tell us and just walk in and see. Usually daily 1:30 to 3:30 it's kept open.
Visit rightly.
Please. I would like to have smaller batches of students so that you plan such a way that 1 o'clock to 4 o'clock or 5 o'clock you spend time with some films, so you can see DAE movies. You can go through the books there. We are planning to make it very friendly so the students come and spend some time and understand what nuclear energy is.
Thank you, madam. Thank you very much.
So thank you. Thank you.